In the 1920s, ships with sonar began to map the seafloor, showing that the ocean floor was not flat, but much like what we see at Earth's surface. There are valleys, mountain chains, plains, and very deep trenches. During World War II, sonar technology improved, and the seafloor could be mapped at very, very great depths in the ocean. Between 1950 and 1960, continued exploration of Earth's crust and the seafloor renewed interest in Albert Wegener's theory of continental drift. An under-ocean mountain range, the mid-ocean ridge, was discovered. Let's go ahead and take a look at the mid-ocean ridge. Let's see here. So here is the mid-ocean ridge, or it's also called the mid-Atlantic ridge because it's in the Atlantic Ocean. So here you have North America, the United States here. You have South America, and you have Africa. So between the two, you have this long range of volcano here called the Mid-Atlantic Ridge. Then in 1956, scientists found bands of strong and weak magnetism along the ridge. The patterns of the bands showed that the seafloor was spreading along the mid-ocean ridge. In 1962, Henry Hess proposed that magma pushed upward along the ridges to form new crust. So Henry Hess proposed here that here's the mid-ocean ridge right here, that the magma came up and then spread out. So the magma would go to the right on this side, and the magma would go to the left on this side over here. This led to the development of the theory of plate tectonics, which we will learn later on. During the 1960s, as the seafloor was further mapped and data from earthquakes and volcanic activity was recorded, the theory of plate tectonics became more broadly accepted. Okay, so we're going to talk about the new evidence that supports plate tectonics. And we read about sonar, we learned about the mid-ocean ridge and the volcanic activity and the patterns of the bands of the seafloor was spreading along the mid-ocean ridge. So let's go and take a video what that looks like.
While some plates crash together, others tear apart. It happens under the ocean. Like here, in the middle of it happens under the ocean. Like here, in the middle of the Atlantic. Lava erupts at the boundary between two crustal plates, sealing the tear. This is the Mid-Atlantic Ridge, a 10,000-mile tear on the floor of the Atlantic Ocean. The ridge is a line of underwater volcanoes, and it's here that new oceanic crust is formed. It stretches from the South Atlantic all the way to Iceland in the north, where it rises above sea level. From the air, the Mid-Atlantic Ridge is an awesome sight. This dramatic scar in the landscape marks the boundary between the North American crustal plate on the left side and the European plate on the right. The gap between ocean plates is filling in at a rate of an inch a year. Part of the restless movement of the Earth's crust that's reshaping our world.